So we're only going to focus on figure A to start. I think we're going to look at doing all of figure A first. So figure A, if a side length is 4, this side length is also 4, which would give us an area of, I'm going to write 4 squared, but we know that's 16. Okay. So same, if I have the same square and a side length is x, what's x times x?
4x.
Try again.
X squared.
X squared.
X squared.
Okay. And if I have the same square and my side lengths are 4x, it's 4x squared, which is 16x squared. So if you're having trouble seeing that 16x squared, 4x times 4x, it's all multiplication, right? So you can use your commutative and associative properties to say 4 times 4 times x, right? You can multiply in any order. And then if one side's x plus 3, what's the other side? Yeah, so I have x plus 3 times x plus 3, or x plus 3 squared. How do you feel about figure A? Okay, what's the only difference with figure B?
It's the same thing except it's subtract 1.
Subtract 1. So I want to see you guys with your partner try to figure out that second column for area of B. So for B, if I have a side length of 4, that's 4 squared, take away that little square, right? If I have, yeah, it's 1 by 1. So if it's x, I don't know what the parentheses would do, but you could have parentheses around the 4 square. So if the side length is x, it'd be x squared, take away that 1. If a side square is 4x, that'd be the 16x squared minus 1. And if it was x plus 3 side length, x plus 3 squared minus 1. What's the difference for the third one? There's 2 what? Instead of 1 squared, there are 2 squared. Let's see what you get for that third column. So for C, here's what I'm noticing. I have 2 of these 4 squareds, right? So there's a couple ways you can write this. I'm going to write it like this. I have 2 of those 4 squareds. And then one more thing. That's supposed to be a plus. Well, this one actually is going to be a plus 1.
Oh, no, I didn't use this.
Okay, so if it's x squared, how many of those x squareds do I have? 2 of those x squareds plus 1. Yeah, if I have 2 16x squareds, that's actually 32x squareds plus 1. Right, if this is 16x squared and this is 16x squared, I have 2 of those, that's 32x squareds. Okay, and then the last one, I have 2 of these x plus 3 squareds plus 1. So we're going to take note, the jump from here to here is no difference. Obviously, what shape are we focusing on? Square. When the square's popping, we're in quadratics, right? So if we have x squared of some sort, that's how we know we're in this new unit, quadratics. What's the difference between that and an exponential? Micah?
Grows by different factors.
Yeah, exponential is like a b to the exponent was x, not 2. Right? It could be 2 for the second one, but the exponent is what's changing. And then for linear, x is to what power in a linear? 1. Okay, so they're different, right? An exponent of 1, an exponent of the variable, an exponent of 2. We have different functions depending on the exponent. So right now we're in the quadratics, which has an exponent of 2. Here's what you're going to do next. We have these pictures. And sometimes I like to use dots for these things. Oops. If you need to draw, like I'll do dots like this instead of the squares. If you need to draw, sometimes the dots are nicer in the notes. But what you need to do is say how many squares are in 5 and 18. The reason they say small squares here, guys, is because like this is a square and this is a square, right? So how many small squares in 5 and 18? You know me, which number am I going to first? No, I'm going number 2 first. Why? I'd use the function myself. You may choose to like use your pattern then to find the function. And then you're going to sketch the first 3 steps of this function. Different one. Step 1, step 2, step 3. With your partner, let's go. So you know me, I'm going to go problem 2. And I'm going to tell you what I'm seeing. And hopefully you're seeing the same thing. Is everybody seeing the square in the middle? That's the number of steps, I hope. Yeah. Okay, so 3 by 3, 2 by 2. And then there's always how many more?
4.
So I'm going to say n squared plus 4 is my function. It's always the step number squared. So if I want the fifth step, the square in the middle is going to be 5 by 5 or 25 plus 4 more. 29. Step 5 is going to be 29. And then for 18, 328 is what it ends up being. I did it in my head first hour. It was very impressive. I think I did 18 times 10 plus 18 times 80 plus 8 times 8 and put them all together. But I might have exhausted my brain power in the first hour. But I really did. You can ask them. And I didn't even just say, hey, I'm going to tell them to ask you lie. I really did it, okay? So, those are our two. We know it's going to be always the number squared, the step squared plus 4 works for all these pictures. We're going to continue looking for squares. Instead of drawing squares for the pattern below, I'm going to draw dots. I like doing the dots. I just feel like it's cleaner and easier. So, if I had a step 1, what's 1 squared?
0.
1 squared is not 0. It's 1. And what's 1 minus 1?
0.
Okay, step 1's done. Step 2, I need a square. My square is going to be what?
2 by 2.
Yep, 2 by 2. But it's minus 1.
3.
So I'm going to take away 1. Okay, and then step 3, it should be what by what?
3 by 9. 3 by 3.
3 by 3, which is 9. But then I need to subtract 1. And you might have subtracted 1 from a different spot. Are you right? Yeah, math is creative. You could, sometimes I'll see like a kind of a middle one, but it doesn't work with the step 2 well. Yeah. But it could be any corner would work. And it doesn't have to be a corner, no. For 2 it has to though. Any questions about how we came up with those steps and how it translates? So, is this quadratic?
Yes.
Yeah, it's got an n squared. We're going to be looking for squares, friends, okay? So as you get to your homework and you're looking at different patterns, what shape are we looking for? Squares. Because a quadratic function has something square. All right, you're going to look at this pattern. Do the next step. You're going to agree or disagree with Kieran, and you're going to agree or disagree with Diego and Jade. You're going to see who's right. So, sketching the next pattern, I'm going to use the dots for step 4. So here's what I saw. I saw like a square of the step, so I saw it different. And then I saw 2 more rows. So that's what I saw. So I saw the square and then 2 more rows above. Now Kieran says it's growing because as the step increases, the side length goes up by 1. So here's what Kieran's saying. Here's the step number, right? N, 1, 2, 3. And she said, well, this one was n plus 1. Sorry, n plus 2. She's saying, if this one is n plus 2, and this one is n plus 2 more. So she's seeing those 2 stacked on top. You guys seeing that, how you could look at it growing like that? Okay. So a row and column each increases by 1 each time, what's she saying? Okay. Then when we get down to Diego and Jada, they see it happening too. They actually see it growing different. Do you remember a couple lessons ago we said we explained how we saw things growing and we could kind of see them growing different even though it's the same? So I actually who said that they see it growing like Diego sees? That n and then the n plus 2 thing. And n plus 2. And n plus 2. Like the 2 more on top. Who saw that? Okay. Who said that they saw it more like Jada? Yeah, I see it like Jada, but I kind of love when someone shows me another way. So what I keep seeing is
What's Jada's way?
Jada's seeing the square
And then just adding 2.
and then 2 rows on top.
Oh, yes.
Okay? So that she's seeing the n squared and then the 2 rows for increasing each time. And what Diego's seeing is the base being an n, or the step, and then the height being the step plus 2 every time. Well, who do you think's right? Both. Look at this. If you were to distribute, if we were to distribute that n for Diego's, look what we get. Everybody see? They're the same. They just see the pattern growing different. Either way, what do we need to find though?
N squared.
An n squared. All right, we're looking for the squared. Right here's the n squared with the distribution in Jada's. Right here's Diego seeing the square in the pattern. All right, same thing, only different. So I'm looking for a square. I'm going to circle the squares I see. You guys see those squares? Okay. So every time I see that square, it is a step squared or an n squared. So what's left? I got 1, 2, 3. I just got n. So last time in the lesson, right, we had 2 rows. This was only 1 row. You also could have written n times n plus 1. This is always n on the bottom, and the side is always n plus 1. So that's the other way you could write it. Is it quadratic?
Yes.
How do we know it's quadratic?
Because there's an n squared.
Because n squared, n times n there is n squared. Let's go. I'm going to hand out the homework.